Okay, problem number 16, chapter 2. This is a fractions problem, and we're going to go through it, solve it. It's an inequality. As you can see here, it's a less than sign. Okay, so there's some things you need to know. Less than, equal to, greater than, equal to, and then there's less than, and then there's greater than. Okay, so these are less than, equal to, less than. Okay, and then greater. Equal to. And greater than. Okay? And just remember, you read it as you do from like a book. From left to right. Less than is on the left side. Less than and equal to. Alright? So less than equal to, or just less than. This one's bigger as you're reading it from left to right. So it's greater than. Okay? Greater than or equal to. Greater than, equal to. So, alright. That means this side's less than, and this side's greater than. The open area eats the bigger number, kind of thing. Alright, let's do this. Again, parentheses, done. Exponents, there are none. Multiplication, division, from left to right. So I start here and I bring it through. Everybody on the block gets the paper. So I have 1/2 x. Notice I write it as a 1/2 x instead of x over 2. They're the same thing, but this is less confusing. Okay? And then this I'm going to write just as, because remember, this is really 2 over 1. So I want to write that as 2 times 1 and 1 times 2, which is 2 over 2. Oops. But one thing I want to make sure I do is keep the sign in there. So it's minus 2 over 2. And then I'm going to bring down 5. But in this case, I'm going to write 5 over 1. Okay? So that everything is in fraction form. Okay? So if I'm going to have fraction form over here, I want to put it in fraction form over here. 4 over 1. And remember, keep the x to the side. It'll make it easier. Okay? Minus, and in this case, I got to take this and give it, everybody on the block gets the paper, the whole paper. Okay, and the negative goes with it. So negative 1/2 times x is negative 1/2 x. And negative 1/2 times 3, remember it's 3 over 1, so it's 1 times 3, or negative 3 over 2 times 1, 2. Okay? So, everybody on the block got the paper. Alright? And now, what we want to do is collect like terms. But that will be difficult, because in order to collect like terms, I have to have denominators the same. You can't add this to this. It doesn't work, right? The denominators have to be the same. So I'm like, wait a minute. I don't want to deal with fractions if I don't have to, right? So this is an equation. And in equations, you don't have to deal with fractions. You don't have to deal with decimals. You can get rid of them, okay? With decimals, you get rid of them by multiplying by the whatever number, you know, if it's like 0.02, I'm going to multiply this by 10, or 100. And it'll move it over 2 zeros, moves it over 2 places. And now it becomes a 2. Well, with this, I want to multiply it by their common denominator. So what denominator is common? So what number does 2 2, 1, 1, 2, and 2 all go into. So what number does 2 and 1 go into?
Would it be 2?
2, yeah. So, but I want to do it to everybody. So I multiply the whole thing by 2 over 1. And what that does is it gets rid of all the denominators. In this case, 2 goes into 2 once, right?
Right.
So now I'm just left with 1x. In this case, 2 goes into 2 once, right? And 1 times 2 is
2.
2. In this case, 1 goes into 2 how many times?
1, 2.
2. So it's 2 times 5, which is 10. Okay? Now, in this case, 1 goes into 2 twice. So 2 times 4 is 8x. In this case, 2 goes into 2
2 once.
once. So 1 times 1 is
Once.
1x. Or just x. And in the last one, 2 goes into 2
Once.
once. So 1 times 3 is 3. Okay? So it's just this guy, this guy, this guy, this guy, this guy, and this guy. All the way through. Everybody on the block gets that paper. And once we do it, then we have this. Now, this is just like before, when we have just regular numbers. And we're back to normal solving of equations.
You know, my question is on the top, the very top, you have 1/2, and you have in parentheses x minus 2. And then you
Yeah.
bring it down, and when you bring it down is minus 2 over 2.
Yeah.
See? Okay, so now I go over to the next one where you have 1/2, and then in parentheses you have x plus 3.
Yeah.
But why is that a minus right there and not a plus?
Ah, because this minus. This minus changed this plus to a minus, and this minus changed this plus to a minus.
Oh.
That's a good question. Okay? So that's what I mean by when everybody on the block gets the whole paper. Not just the bulk, but you want to give those inserts too. And this is like those inserts. This is the other part of the paper on the inside that you have to give with it. So they get the whole paper. So negative 1/2 times x. And negative 1/2 times 3. And that's why we get a negative 1/2 x and a negative 3 over 2. Does that make sense? Okay, good. So, here we are. Again, just back to collecting like terms. So now I just want to collect my like terms. So I know that this is like on this side, and these are like on that side. So I collect them up. And minus 2 minus 10,
8.
yeah, that's what most people think. No, it's not 8. Not 8 because, remember,
12.
yeah, they're the same sign. And when they're the same sign, we add them. Okay? It's really tough to remember that. A lot of times I do a plus minus here, and then it's like, oh, I'm adding a negative. And when they're both negative, so that is a tough one. It catches people all the time, but it is minus 12. Okay? So you can think of it as minus 2 plus a minus 10. That's a little easier to think about.
But it's still minus, but it's added up.
Yeah,
12.
it's like I borrowed $2 from you, and then I borrowed 10 more.
Now you owe me 12.
I owe you 12. I'd like to owe you 8, right? But that would be wrong. Okay? So, and in this case, they're different signs. So when they're different, it gets smaller, and when they're the same, it gets bigger. The numbers do, right? The actual number is actually smaller, technically, but you get what I'm saying. So 8 minus 1?
7.
7. Okay, and then we just have that. Okay? So we're almost there. And remember what I said here. Always, always grab the lowest x. The lowest x. It's so crucial. And this is why I've been pushing that so hard. Because when we get to these, and you divide or multiply an equation by a negative number, you have to flip the sign. But when you move the lowest x, you'll never have to multiply by a negative number. Okay, and I'll show you what I mean as we go on. Okay, so I move this x, because 1 is less than 7, right? So I'm going to move this x, and I'm going to add the opposite to both sides. Okay, so now I have negative 12 is less than or equal to 6x minus 3. Okay, now I'm going to move this 3 away from the x. So I add the opposite, right? What's the opposite of negative 3? Positive 3. Alright? So I have negative 9 6x. And now I come back to that whole fraction thing. But now I don't care that it's a fraction, because it's in my answer. So, and this is that part where I solve for x. So I divide by 6, and I get negative 9 over 6 is less than or equal to x. Well then, another way to look at this, I'm going to bring it right up here. Negative 9 over 6 is less than or equal to x. Okay, so I gotta reduce that fraction a little bit, right? And if I multiply it by 3 over 3, what happens is the 3 goes into 9 how many times? 3 times. And the 3 goes into 6 how many times?
2 times.
Yeah. See, and what I'm doing is I'm multiplying it by a 1, right? 3 over 3. But it's enabling me to reduce it. That's how we truly reduce fractions. So now I get negative 3 over 2 is less than or equal to x. But the problem is a lot of times our x's are written over here, right?
Right.
Well, write it over there. But remember the big sides towards the x?
So it just changed the...
Yeah, now we flip the sign, but we do it logically. Rather than flipping the sign because I multiplied by a negative, where the heck did that come from? It's a rule. It's a rule of thumb. It's what, all it is a trick. It doesn't actually, it doesn't, it's a trick that you have to do, but it shows no meaning. It's just the rule that they're telling you to do every time you do something, but there's no meaning behind it. Here, there's a meaning. I'm moving my x to that side, so I have to keep this pointed at that. Or this pointed away from the x. It always has to be, I can't change it, right? That would be wrong. So, this and this are the same thing, except this one you'll find on the test.
So the answer is x is greater than or
equal to
3 over 2.
Yes, x is greater than or equal to 3 over 2. Negative 3 over 2. And there you go. Oh, just in time, 15 minutes.